This video is on finding the limiting value of a sequence. Now I have the nth term of a sequence is 1 over n. Now I'm going to start by writing some terms of this sequence. So the first term is going to be 1 over 1, which is equal to 1. The second term is 1 over 2, which is a half. Third term is 1 over 3. So what I'm noticing here is I started with 1 and then it became a half, then it went to a third, so it's getting smaller. So I'm just going to skip a few and see what happens. I'm going to go to the 10th term. 10th term is 1 over 10. Okay, I'll just write this as a decimal as well, 0.1. And I'll go to the 100th term now, 100th term. Okay, and this is going to be 1 over 100, and that's equal to 0.01. Okay, let's go to the 1000th term as well. So 1000th term, and this is going to be 1 over 1000, which is equal to 0.001. Let's go to the millionth term. So the millionth term, and then this is going to be 1 over a million. Okay, and then that's equal to 0.000001. Okay, so what I'm noticing here is that it's getting smaller. So the first term was 1, then it became a half, then it's a third, then it's 1 over 10, which is 0.1. But then when I go to the 100th term, it's 1 over 100, which is 0.01. 1000th term, 0.001. A millionth term, 0.00001. So you can see what kind of pattern is developing here. So if I make n really, really big, I'll get a really small number. So what we can say is this. So let's write this now. As n tends to infinity, so this arrow, we read it as n tends to infinity. So as n here tends to infinity, then 1 over n tends to, okay, so what does it tend to? So here it's getting smaller and smaller, and then we skip some, and then it's getting smaller and smaller and smaller. So as it's tending to infinity, so if I'm looking for the infinitieth term, what is happening? It's getting really small, so this is going to tend towards 0. So this is going to tend towards 0. So as n tends to infinity, then 1 over n tends to 0. So the limiting value of this sequence is going to be 0 as n tends to infinity. Now let's look at another one. So we've got here the nth term of a sequence is 8n minus 5 over 2n plus 3. Again, I'll start the same way. So I'll find the first term. First term is 8 times 1 minus 5 over 2 times 1 plus 3. And that gives me 8 take away 5 is 3. And 2 plus 3 is 5. So 3 over 5 is the first term. I'll skip a few. I'll go to the 10th term. Okay, so I'm going to have 8 times 10 minus 5 over 2 times 10 plus 3. Okay, so 8 times 10 is 80, take away 5 is 75. And 2 times 10 is 20, add 3 is 23. So let's see what's happening here. This is 3 over 5, which is less than 1, and then this is 75 over 23, so it's getting bigger. Let's try again. Let's try the 100th term. So the 100th term is 8 times 100 minus 5 over 2 times 100 plus 3. and then this is going to be 795 over 203. Okay, and let's try the thousandth term. So this is going to be 8 times 1000 minus 5 over 2 times 1000, so 1000, add 3, and that's going to give me 7995 here, and I'm going to have 2003 here. So now let's compare these ones. So this is 795 over 203. This is 7995 over 2003. So I can see that if I was to make this a lot bigger, like a million, for example, it would just be 5 less than 8 million at the top, and it will be 3 more than 2 million at the bottom here. And I can see also that this is quite close to 8,000. This is quite close to 2,000. Say, for example, I had a million here. It would be really close to 8 million here, and it would be really close to 2 million here. So what I will have is, if I was to estimate the value here, I would round this to 8,000, this to 2,000. So 8,000 divided by 2,000 is 4. And the same I can say for, if I was to look at the millionth term. Let's look at the millionth term. So the millionth term, okay, this is going to be 8 times 1 million minus 5, and this is going to be 2 times 1 million, add 3. So this is going to be equal to 7,999,995, and this is going to be 2,000,003. Okay, so let's compare these two. So I have here 7,995 over 2003, and we said this is very close to 8,000, this is very close to 2,000. 8,000 divided by 2,000 is approximately 4. So it's approximately 4. What about this one? This is very close to 8 million, and this is very close to 2 million. Now this is also approximately 4, but this is actually closer to 4 than this was. And I know if I was to go even further, I'll get another value that's going to be even closer to 4 than this is. So as this is getting really, really big, I can see that my value here is actually getting closer and closer to 4. So what is happening is the limiting value for my sequence here, 8n minus 5 over 2n plus 3, I can see that it's going to be 4. But what if this was an exam question? What will I do? How will I show this? So this is what I'm going to do if it was an exam question. So I'll start in red now. So if it was an exam question, this is how I'm going to answer this. So I have 8n minus 5 over 2n plus 3. And I need to show what the limiting value is as n tends to infinity. Okay, so what I can say is, as n tends to infinity, 8n minus 5 over 2n plus 3 gets close to, or I'm going to say actually equals to 8n over 2n. Because as n goes to infinity, this minus 5 and this plus 3 become less and less important, like we saw here. So here this minus 5 and the plus 3 was a little bit important, but there it became less important because I'm even more closer to 8 million here than I was to 8,000 there, and I'm even more closer to 2 million here than I was to 2,000 here. So this minus 5 and this plus 3 become negligible. So as n tends to infinity, 8n minus 5 over 2n plus 3 is equal to 8n over 2n, because because the -5 and +3 become negligible. Okay, now I have now 8n over 2n. Now that actually simplifies to 8 over 2, and 8 divided by 2 is equal to 4. So 8n over 2n, I know the n's will cancel, and then I'm going to have 8 divided by 2, which is equal to 4. So the limiting value of this sequence here is going to be 4, and I've shown this algebraically here with a comment as well. And here I just done it using some different terms and looking at the results and how that works, but this is how you would answer it in an exam. Now have a go at some of these questions. Okay, so answer these questions and also answer this question: what happens to the sequence 2, 5, 8, 11, 14 and so on as n tends to infinity, and how is this different from the questions above? So answer these questions and bring that to the lesson.